Hello students, welcome to Managerial Statistics lecture on chapter 3. In this part, I am going to discuss about mean, median, quartiles and more. And with regards to measures of central tendency, this is outcome number 4 will be covered on chapter 3 and I have also cited the reference below for further clarity and understanding. Now, what are the topics covered with regards to this outcome? Let us focus. So, at the end of this chapter, students will be able to understand about mean, both simple and weighted computation advantages and disadvantages, and also about median, how to calculate what are its advantages and disadvantages, and also quartiles and its computation, and also about mode, its calculation, advantages, and disadvantages. So these are the topics we are going to cover in this chapter with regards to mean, median, quartiles, and more. So let us understand the measures of central tendency. What are the items mainly we are going to cover? Here it highlights, talks about mean, median, and mode. And this is how I'm going to show you from the central tendency how to calculate mean, median, and identify mode, and how it deviates from the average, whether it is far or more. In the later chapter, I will be explaining. Now, let us understand the meaning of averages. What is the meaning of average? Suppose if I ask you a question, what is your CGPA? So what do? You make the total of all your courses and divided by number of courses you study in a semester. That will give you cumulative grade point average. We call this as CGPA. Same here too. An average is a figure which represents the large number of observations in a concise or single numerical data. So you will be given a set of series of number. You need to total and count how many numbers. When you divide, you get the average. So it is a typical size which describes the central tendency. It is a representative value around which all the values of variables cluster or concentrate. So this is with regards to average. I hope this slide information is very clear to understand with regard to average. Keep in mind, in a series of number which is given to you, you need to just sum and divide it by number of item. So you will get the average. Now let me make you understand with regards to measures of central tendency. As you can see the picture, center, from the center, we are going to identify mean, median as well as mode. So now you can understand from the central tendency, that is measures of central tendency, or we also say measures of central location. So now you can understand central location. So between the given set of series, the mid center. So averages of the first order describe the concentration of large numbers adequately around the central tendency. That is what the picture example is talking about. So I hope this information is very clear to understand with regards to the central tendency. And also, moreover, we need to understand an average is a set of summary figures. So, this is what, with regards to mean, median, mode in central tendency, will reveal its average in a set of summary figures. So, now let me make you understand what are the objectives of statistical average. So, everything has an objective. Now we need to understand why do we calculate and what is the objectives. The first objective of preparing statistical average, it will give or present complex data in a simple and concise form. So a complex data in a simple average, it will make anyone to understand very clearly. So this is the first objective. The second objective, it will facilitate the data for comparative study of different series. So you can make comparison very easily if you get the average, whatever, how many number you wanted to get, how many division. If you get the average, comparison will be very simple, and for making decision also it is very essential. So this is the second objective. The third objective is to study the mass data population from the sample. So we can take from the population a sample, and what the sample analysis talks about, we can understand with the help of statistical averages. And also to establish relationship between two series. So when you are making a study within the two series, what is the relationship? Whether the relationship is positive or negative can also be understood with regards to statistical averages. And also to provide basis for decision making. Mainly we are taking this average for making decisions, maybe in study or maybe in business or whatever it is. And also to calculate the representative single value from the given data. So whatever may be the large volume of data, we get a single value. This single value will be highly useful for making decision, for making comparison, or whatever way it can be understood in a simple and concise form. So these are the objectives of statistical averages. So I hope this example and information is clear to understand. Now let us go on to the requisites of a good and ideal average. The first requisite, when you prepare an average, it should be easily understood. If you are making it, either it may be myself or yourself or anyone should be in a position to easily understand. So this is the first requisite. The second requisite is it should be simple in calculation. It should not be complicated. It should be very simple. The third one, it should be based on all observation. So total observation, it should be taken. It should not be ignore any one or two value. So everything has to be taken. So it should not be unduly affected by extreme values. So extreme values, it should not get affected. It should be rigidly defined, very clearly it should be defined, and it should be capable of further algebraic treatment. So whatever calculation you are making, it should be easy, simple, and for further calculation like further algebraic treatment, it should be useful. In that way, it should be prepared. And also it should have sampling stability. 3 or 4 sampling sets must be that is it must give the same or similar results. So this is with regards to the requisites of a good and ideal average. So I hope this information is clear. Now what are the problems, limitations, drawbacks with regards to statistical averages? Let us see one by one. The first problem here, extreme values, if any, will affect the averageable figure disproportionately. So here, what happens here, extreme values with regards to average, it will affect the averageable figure disproportionately. The second point, the composition of data cannot be viewed with the help of average. So what is the composition? What are the other details cannot be known with only the average? So this is the second limitations. The third limitation is the average does not represent always the characteristics of individual item. So it takes only group items, individual item, it cannot talk about the characteristics. So this is the third limitation. The fourth limitation is the average gives only a representative figure of the mass but fails to depict the entire picture of the data. So it gives only an average, but the holistic approach, the true story, it doesn't talk about. So these are all the limitations of statistical averages. So I hope this information with regards to this part is clear to understand. In the previous slides, I had explained about what is the meaning of averages, central tendency, what are the objectives of statistical averages, what are its requisites and limitations. Now, in this part, let us focus on the various types of statistical averages, and also I'll be explaining about what is the meaning of arithmetic mean, weighted average mean, what are its merits, demerits with simple problems. So let us focus on the types of statistical averages. We have mathematical averages and positional averages. In mathematical averages, we have simple arithmetic mean and weighted arithmetic mean. In positional, we are going to see median and mode. So these are the various types of statistical averages. Now let us focus on what is arithmetic mean. Suppose if I ask you what is average? Average means, for example, your mark. So you total your number of courses you study, your marks total divided by number of course, you get the average. Here you say CGPA. It is the same. Arithmetic mean is the most widely used measurement which represents the entire data. It means in a given set of series, total of all, that is sum of all total divided by number of item. So that determines arithmetic mean. So generally it is termed as average to a layman. So another way to understand arithmetic mean is nothing but average. It is the quantity obtained by dividing the sum of values of the items in a variable by their number. This is what I explained. So whatever series of number given, make the total divided by how much number of item. So arithmetic mean, here it is divided into simple arithmetic mean or weighted arithmetic mean. We have two. So it is denoted by a symbol called X bar. So X bar is nothing but the representation of arithmetic mean. So what are the advantages, merits of arithmetic mean? Let us see one by one. It is simple to understand and easy to calculate. So the first merit, it says, is very easy. Making total is very easy, and to calculate also it is easy. The first merit. Second merit, it is computed correctly and the figure is exact, suitable for further mathematical treatment. So whatever series of data, you calculate them correctly, and when you determine the average, it is useful for further mathematical treatment or calculations. The third advantage, it takes into consideration every item in the series in computation. Whatever the number series it is given, it takes all the total and divided by number of items. So it is not necessary to arrange the values in an array form. This is the most important part. While calculating arithmetic mean, no need to arrange from highest to smallest or smallest to highest, just to make the total divide by number of items. So it is the center of gravity which balances the values on either side. If you draw a line, keep exactly the mid center point. See, this is what we call center of gravity, which balances left and right. That is the values on either side. So I hope this example is clear with regards to merits of arithmetic mean. So let us move on to understand what is the demerits of arithmetic mean problems. Okay, problems, demerits. So the first demerit, it is affected by extreme items. The second demerit, it may not be, that is, it may not be the one item among the given value of variable. It takes only set of item. So this is the second drawback. One item, it cannot give anything. So set of item average only we can identify. The third one, it may represent fractional figure. So it may come in decimals, 13.05 or 75. So these kinds of values also will be reflected. It may give wrong impression if proper weights are not given. So proper weightage or miscalculation, it gives a very wrong impression. In case of open-end class interval, midpoints are arrived by making assumptions, which may be wrong. Now, while calculating arithmetic mean, in the case of open-end, after calculating midpoint, what we do is we take any of the midpoint as assumption. So here it says if we calculate by taking assumption, it may be wrong. So these are all the demerits of arithmetic mean. So I hope this information is clear with regards to demerits of arithmetic mean. Now let us move on to see a simple problem or before how to calculate arithmetic mean. So to calculate arithmetic mean, given set of number you need to make total. So this total is what we call sigma x. The Greek word sigma means total. Sigma x means values, whatever given in the series are added together. So this is the first step. The second one, we have to ascertain what is n. N is nothing but count the number of items in the given series. So how many numbers are given? We need to count. For example, if the values are 22, 52, 75, 57, so how many numbers are there? 4. So this is what we call n. And when we apply the formula sigma x by n, it means sigma x, we need to make the total of 22 plus 52 plus 75 plus 57. This will give sigma x. N is 4. So what will be the total? If you calculate, you can identify the simple example total. Now let me make you understand by moving into problems. So given below is the height of 7 students in the class. Find the mean of the given data. So 131, 150, 6, 114, 125, 142 and 103. These are the values of heights of 7 students given. Find the mean. So mean, what is the formula? Sigma x by n. What is sigma x? You need to total from the value starting from 131 to 103. No need to arrange. Okay. And count the number of item. So number of item is 7. So we need to first calculate the n value is 7. Then we need to apply the formula mean is equal to sigma x by n. Sigma x total is 861. So 861 divided by 7, we get the answer mean is equal to 123. So let us see one more small example problem the following information is provided to you. The average age of 80 boys in the class is 10. We need to be very careful. Average age is given 80. Okay. The average age of 20 girls in the class is 15. Find the average age of the boys and the girls taken together. So the challenge here given to you, you need to find boys and girls together. What you need to find? Average age. So what is the step we need to do? Step number one, we need to ascertain n. How to calculate n? You see the first line, 80 boys and 20 girls average. This two total we get n is equal to 100. Now sigma x for boys. So sigma x is equal to sigma x by n. We know this is the formula. Now mean is 10. So this is what? Let me show you the first step. Can you see the average age of boys in a class is 10. So this is the x. Okay. And sigma x we don't know. This is what we have to understand. That is why I have written here sigma x. And this 80 is the average age of boys 80 given here in the problem. So what we need to do? We need to cross multiply 80 into 10. We will get sigma x 100. Same way when we do for girls, 20 into 15, 300. So this is how we need to calculate sigma x values for boys, sigma x values for girls. And then we need to add the total of 800 plus 300 will give us the total 1100. So 1100 divided by 100, we will get 11. This is the next step we need to calculate to find mean for boys and girls. Total is 800 plus 300, 1100 divided by 100 will give the answer 11 years. So the average age of boys and girls is equal to 11 years. So this is the solution for this simple problem. So I hope this example is clear. Now let us take one more example. Problem number 3. Mr. Mohammed has appeared for 3 tests of the values 20, 50 and 30. Now in the problem it is given, in the first he scored 75%. In the second he scored 60%. And in all the tests together he scored an aggregate of 60. So first one, so in the first test he scored 75%, in the second he scored 60, and in all the tests together he scored an aggregate of 60. So find the percentage mark in the third test. So this is the challenge we need to solve. Step number one, we need to calculate the total mark scored in all tests. So total mark, as you can see in the first line, it is given first test 75, second he scored 60, all test aggregate is 60. So we need to take in all test aggregate 60 of 100 is equal to 60 mark. Okay, this is step number one. Step number two, total marks scored in first test, 75 percentage of 20. As you can see here in the problem, the first mark is 20. So 75 percentage out of 20, you will get 15 mark. Okay. Now we need to take total marks scored in second test. Second test, as usual, it is given 60, but the mark here is 50. So 60 percentage of 50 will give you 30. Now what to do? The next step, we need to calculate the marks scored in the third third test. So 60 is the mark scored in all. Okay, that we need to take. So marks scored in first and second, we need to make the total reduced with 60. So we will get 15. What is this 15? This 15 is nothing but third test score. So this is a simple problem to calculate marks, to find the percentage of marks. So I hope this simple example is very clear to understand. Now, let us understand what is weighted arithmetic mean. Here, the quotient is the weighted arithmetic mean or average. So how we calculate here? We calculate the weights by taking W1, W2, etc. And X1, X2 are considered to be the values. So weights are number or percentages which stand for the relative importance of the items. How do we calculate symbolically? We take weighted arithmetic mean is equal to sigma wx divided by sigma w. So this is how we calculate. We take the weights or percentages divided by sigma w. So this is how we calculate with regards to weighted arithmetic mean. So I hope these examples are clear to understand. So dear students, in the previous slides I had discussed about the various types of statistical averages, arithmetic mean, merits, demerits with simple problems and weighted arithmetic mean. Now I am going to discuss with problems on weighted arithmetic mean. Let us see problem number 1. Calculate simple and weighted average price of coal purchased by an industry for the half year and account for the difference between the two. So the table details are given starting from month January to June. Price per ton is also given. Tons purchased is also given. So by taking this problem, how to solve in weighted arithmetic mean, let us see now. First, we need to know how to calculate the simple arithmetic mean. So this is the step. We need to take the total of the uh, values given and we need to calculate sigma x. So after calculating sigma x, we need to apply formula, that is mean is equal to sigma x by n, which will give you 294 divided by 6 will be 49. So let me further explain very clearly. This is how we need to take up the values x, w, that is price per ton. We have to assume variable x. Tons purchased will be w, and we need to calculate what is wx. Wx is nothing but tons purchased multiplied by price per ton. That is 25 into 42.5, 1062.5. So like this we need to calculate for all the total. When you make the total of the first price per ton, we get sigma x is equal to 294. Now, when we make the tons purchased total, that is W, we get sigma W 200. Now, Wx after multiplying and calculating, we get sigma Wx. The value here is 10,072.5. Now, we need to apply the formula weighted arithmetic mean. That is how we have calculated by using the weights. So, weighted arithmetic mean is equal to sigma wx divided by sigma w. This is the formula. So, 10,072.5 divided by 200, the total will be 50.3625. So, this is the solution with regards to this problem. So let me explain the same problem. You need to very keenly observe. On the top, I have made using price per ton as W. Okay, price per ton, I am assuming that W, tons purchased as X. So the weighted arithmetic mean here it will change. it is not the same what I had done earlier. Here it will change. Why? Because tons purchased I assume as X, price per ton as W. Clear? So sigma W will be 294, sigma X will be 200, Wx you multiply, it is the same value. Now, when we apply the formula, the result here, it will be 34.26. So this is the difference between the previous problem and the current problem what you are focusing now. Why? Because here I have used price per ton as W and the tons purchased as X. So that is the difference it has created between earlier problem and this problem. So I hope this example is very clear. In order to calculate the weighted arithmetic mean changes. Okay, how it changes here. Now let us see one more problem. Here you need to comment on the performance of students of two university given below using simple and weighted averages. So Bombay and Madras University and courses are given MA, MCom, MSc. So we need to calculate using simple and weighted averages. How to solve? Now I'm going to tell you step by step. Now let us take the same problem. Now first step, give the heading. So we need to give Bombay and Madras University, and you can see percentage pass, number of students are given for Bombay as well as Madras University. Percentage of pass is X and the number of students I assume W. So we need to calculate Wx, same for Bombay University and Madras University. First let us take the courses. We have MA, MCom, MSc. Percentage of pass, as usual, given what is same given in Bombay, we have to take 75, 80, 72. Number of students 300, 400, 500. Now 75 into 300, then 80 into 400, 72 into 500. These are the values we are going to get. Wx. So I hope this step is clear to understand. Same way we need to do for the Madras University. Percentage of pass, as you can see the problem above, 68, 83, 76. Same. Students also we have to take 280, 370, 490. Now 68 into 280, 83 into 370, 76 into 490. So this is the Wx total we get. Now, next step is very simple. We have to make the total. Sigma x, sigma w, sigma wx, you will get the total. Okay. So after getting the total, now we calculated the problem and we have calculated the result. Now we need to identify weighted average mean for Bombay University and Madras University. Now, what is the total? What is the formula? What is the formula, dear students, for calculating weighted arithmetic mean? So, sigma, first we need to take mean, that is calculate sigma x by n. As you can see, the values I am rounding. This is sigma x and n is the total. Total means 1, 2, 3. So, 227 divided by 3 into 100. You need to multiply into 100. Then only you will get 75.667 in percentage. Okay. Then I asked you a question. What is the formula for weighted arithmetic mean sigma wx divided by sigma w? That is 95 divided by 1020. You can see 905 divided by 1200. So if you multiply the result into 100, you will get 75.417. So this is the method for doing for Bombay University. Same way when we do for Madras University, we will get the result. like this. So the mean answer will be same in the case of Bombay and Madras, but weighted average means slightly it differs. So Madras University average is higher than Bombay University. So this is the example. This is how you need to follow the guidelines and rules for solving with regards to weighted arithmetic mean method. Now let us see one more problem. The data represents the number of people who died due to road accidents from 9 different regions in Sultanate of Oman. So it is given in the variable x. So what we need to do first to make the total, whatever value 206 to 305, if you calculate in your calculator, you will get 2699. Now, next, how many number of items given? If you count, it will be 9. So what is the next to calculate simple arithmetic mean formula? Sigma x by n. So 2699 divided by 9 is equal to 299.89. So I hope this example is clear to understand with regards to simple arithmetic mean. Now, find the weighted average price of three models of automobiles sold whose price and number is shown in the list like this. So, model ABC, number, price is given. We need to calculate weighted arithmetic price. How to calculate? So, you see here W, right? W into X, we need to calculate WX. So the result will be 8 into 10,000, 80,000, 10 into 12, 120,000. So 12 into 8,000, 96,000. Then we need to make the total. So we will get sigma x, sigma w, sigma wx. Okay. So with regards to this problem, I will show you in detailed steps in the next coming slides. So I hope up to this part is clear to understand. So dear students, in the previous concluding part of the slide, I told that I will be discussing the same weighted average prices problem in steps in details. So let us continue. So weighted arithmetic mean can be calculated by using the formula for the same previous problem. This is the answer we derive. So sigma wx total will be 296,000 and sigma w will be 30. So 9,866.67. So moving further, let us see problem. Find the weighted average price of three models of automobiles sold whose price and number is shown in the list. So model ABC, number and price. So how to solve this problem? We need to take the model, number, price as usual given, make the total. Okay. So once we make the total, we get sigma x 30, sigma w 30,000. Wx is just a multiplication. For model A, 8 into 10,000, we will get 80,000. Model B, 10 into 12,000, 120,000. Model C, 12 into 8,000, 96,000. So once we make the total, we get sigma Wx to 96,000. So I hope this step is clear to understand. So let us proceed. So in this regard, weighted arithmetic mean can be calculated by using the formula. I'm going to show you. After using the formula, this is the result we calculate. So sigma Wx is 296,000 divided by sigma W 30,000. So 9.867. This is the result. So in conclusion, what we need to write with regards to the problem we have seen with regards to Bombay and Madras University. So arithmetic mean is the same. So as I shown you in the previous slides, 75.667. On comparing the weighted mean, Madras University is slightly more than Mumbai University. As usual, I told you. So this in your own understanding, dear students, you can write it in your own way. Need not write in the same way. This is just for your information. So I hope this conclusion is clear to understand. So let us see the next part is median. What is median? Median is the value of item in a series which divides the array into two equal parts. One consisting of all values less than it and another consisting values more than it. So it means given series when we arrange and take the mid center, we can identify in one end all less than variables and more than variables we can identify. So this is what we call median. So it means when the values of variables are arranged in an array form, in an ascending or descending order of their magnitude, the value of middle item of array is what we call median. That's what I told you. Median is nothing but the mid center. So whatever may be the series of number, we need to calculate the mid-center value. So when we try to identify the mid-center value of the given series of set of numbers, this is what we call median. So I hope this explanation is clear to understand with regards to median. If not, inshallah, after doing a problem, dear students, you will very easily understand. Median is a positional average. It occupies the central position. So it is the middlemost value in the arrayed distribution. It is denoted by the symbol ME as you see. So median is the size of n plus 1 by 2th item. This is the formula. So n is the number of item. ME represents median, that is the middle number, and this is the formula to calculate median. N plus 1 by 2th item. So how to calculate median value? Let us see. We need to arrange the data in ascending order, apply the formula to calculate the item number, select the data that corresponds to the item found under step 2. If the item calculated is in decimal place, then it will fall between two values. In this case, median is found by calculating average of those two numbers. So with average, without average, we are going to calculate median. So these are the steps. I hope these examples with regard to median value steps are clear. Now, what are the merits of calculating median? What are the advantages? It is very easy to calculate and understand, and it is well defined, just as an ideal average should be. And it can also be calculated in the case of frequency distribution with open-ended classes. It is not affected by extreme value and also interdependent of range or dispersion of data. It can be determined geographically. See, these are all the advantages. Very easy to understand, well defined, and frequency distribution can be calculated. Extreme values are not affected. Graphically, you can easily calculate with regards to median. These are all the most important vital importance advantages of median. Now, not only that, it is a proper average for qualitative data where items are not measured but are scored. So here in it is an average determining the qualitative. Qualitative means, as I explained earlier, like gender or what is the color of cars. These are all qualitative, right? So it is a proper average for qualitative data, and it is suitable when data are qualitative and it is possible to rank various items. So for qualitative data is most suitable and also we can rank it. And also it can be calculated easily by watching the data. Once you arrange, it is very easy to locate median and easy to understand. So in some cases, median gives better result than mean. So when mean is not giving some better result, we need to depend on median, and it is more suitable for qualitative data as well as for ranking. So these are the merits of calculating median. So I hope these examples are clear to understand with regards to this information. So, dear students, I had explained about weighted arithmetic mean problems as well as I had also discussed about median merits. Now, let me explain with regards to demerits, problems of median. So, what are the problems with regards to calculating median? Here, when you calculate, data needs to be arranged in ascending or descending. So if you don't arrange, you cannot determine the middle value. This is the first problem. And moreover, it is not based on all observation. Only a certain set of observation only it is taken. And third point, it cannot be given for further algebraic treatment. When you calculate median, with that it is over. So further calculation or further mathematical or algebraic treatment is not possible. And also it is affected by fluctuation of sampling. So sampling if keeps on changing, definitely it will affect. So results will not be clear. And also it is not accurate when the data is not large. So large amount of data, we cannot use median. It's very difficult to calculate. So in some cases, median is determined approximately as the midpoint of two observations, whereas for mean, this does not happen. Mean, any number of value we can take and we can identify, but median, we cannot do. Large number of data accurately, we cannot calculate and it will be affected. So these are the points connected with regards to demerits of median. So I hope these points are clear. Now let us see how to calculate median with odd number of variables are given. So this is an example problem. So problem is given. You need to calculate median. So as I told you, we need to arrange from small to big. So this is the first step. Arrange the data in ascending order. So as you can see in the given data, 8 is the smallest value. See, starting from 8 to largest value 80, we need to arrange in order. So this order is called ascending order. Step number 2, we need to apply the formula as I told you n plus 1 by 2th item. So this is the formula. What is n? Number of count in the given series of data. So if you count how many it is coming, 1, 2, 3, 4, 5, 6, 7, 8 and 9. So 9 plus 1 by 2, 10 by 2, fifth item is the median. So we need to locate after arranging. You see here 1, 2, 3, 4 and 5. So the answer is 43. So this is step number 4. Hence the median would be 43. So I hope this simple problem is clear to understand to calculate median when odd number of variables are given. So let us see an example with regards to even number of variable. So this is the data. So how much it is given, we need to count. First odd or even we need to find 1. Okay. So let us start to count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 plus 1, 11. See, now what we need to do in this regard, you will get an average. So when you get an average in decimal points, Then we need to take the average. So let us see how to solve this problem. First arrange the data. Okay, as usual, previously I had explained the same step. Then we need to use the formula. So when we count it is 10, so 10 plus 1, 11 by 2 will be 5.5. See now 5.5 it is coming. See 1, 2, 3, 4, 5. In between 43 and 56. So it is coming 5.5. What we need to do 43 plus 56 divided by 2. This is what we need to do for in the case of even number. So we will get the result 49.5. So this is the method when even number of value variables are given. So this is clear. So I hope these points are very clear to understand how to calculate median in the case of even numbers. Now, let me explain what is the meaning of quartiles. Quartiles are positional average like median. As median divides entire distribution into two equal halves, quartile divide entire distribution into four equal parts. So this is what we have to understand. So first quarter we call here first quartile is the lower value below which there are 1/4 of items and above which there are 3/4 of item. So value of Q1 is got by using the formula. In median we will be using n plus 1 by 2. Here you have to use n plus 1 by 4. This will give you quartile 1. Okay. So I hope this information is clear to understand with regards to quartile. So continuing further with regards to quartile, the second quartile, how to calculate? Here, it divides the total distribution into two equal half. Same way, it is also called like median. Quartile formula for Q2 is equal to n plus 1 by 2. The same formula, what we use for median in the second quartile also, it will be the same. Now, Q2, after taking the median formula, how we have to determine is quartile formula for Q2 can also be given as Q2 is equal to Q3 minus Q1. Suppose in a problem, Q1 is given, Q3 is given. They are asking you to find Q2. Very simple. Q3 minus Q1. This is what you have to calculate. Third quartile is the value below which there are 3/4 of the items and above which there are 1/4 of the item. So the quartile formula for Q3 is equal to 3n plus 1 by 4th item. So this is how we need to calculate quartiles. So let us see some problems with regards to calculating quartiles. Q1, Q2 and Q3 values are given 43, 62, 50, 80, 56, 72, 80, 82 to 84. So what we need to do, like median, we need to arrange, okay, in ascending order. So after arranging, we have to use formula for calculating quartile 1. What is the formula for quartile 1? N plus 1 by 4th item. So if we count, n is 11. 11 plus 1 will be 12. 12 divided by 4 is equal to third item. So after getting the Q1 answer, you see 1, 2, 3. The third item is 25. So this is your Q1 answer. Right? Now Q2. How to find Q2? First we will find Q3, then we will go to Q2. So Q3 is 3n plus 1 by 4th item. So 3, n we know already n plus 1 is 12. So 12 by 4. So we will get 9th item. If you calculate this, we will get 9th item. 9th item is 80. So next Q2 is very simple. I told you Q3 minus Q1. 80 minus 25. You will get Q2. See here. Either if you use the formula and locate, or if you take Q3 minus Q1, you will get the same answer. You can cross verify, right? If you use the formula and if you try, the sixth item is 56. as I've shown you in the first step. The second step, Q3 minus Q1, you will get the answer the same 56. So this is how you need to understand how to calculate Q1, Q2, Q3 quartiles. So I hope this is clear. Now, what is mode? The highest number of repeated items in a series is called mode. So mode is the value of variable which is repeated the greatest number of times in the series. So it is the usual and not casual size of item in a series. It lies at the position of greatest density. So if each observation occurs same number of time, we can say there is no mode. So if two observations occur in the same number of time, we say bimode. If three or more, we say multimode. If there are single observation which occurs the most number of time, we can say this is the case of unimodal. So if it is two bimodal, two or the three or more multimodal. So this is the point we have to keep it in mind. Mode is the highest number of repeated item, right? If there are no repeated item, we say no mode. If there are two observations, we call bimode. If there is only single observation, we call unimode. Three or more, we call multimode. So these are the points to be kept in mind for calculating mode. So I hope these points are clear to understand. So in the previous slide, I had explained about median, quartile, and meaning of mode. Now, let us calculate how to determine mode. So, with regards to individual observation, the modal value is determined just by inspection. Generally, an array helps to identify and count values quickly. For example, following are the values of variable. So you have to look into this example and dear students carefully observe this example. Okay, tell me which number is repeated more number of times. I will give some time. Yes, dear students, are you able to identify what is the most repeated item in this regard? Any guesses? Yes, the mode is 64. As you can see in the given values, it occurs the highest number of times, that is 4 times. So the mode is clearly defined. It is called unimodal in this case because that is the one value which has occurred most number of times. So I hope this example is clear to understand. So let us see, the following are the values of variable. You need to calculate mode. Can you determine mode in this regard? Yes, dear students, it is very easy. Can you give a try? Yeah, there are two modes in this regard. One, we can see 175 as well as 234, each occurring 3 times. So when there are two, what is this type of mode called? Bimodal. This is the example called bimodal. Whereas the previous example, only one value occurred more number of time. When two values are occurring, this is what you have to keep it in mind. Bimodal means two values are occurring equal number of times. Okay. So let us see one more practical exercise. The following data is provided to you relating to wages of 15 workers in a factory. Now, you need to calculate mean, median and mode from the data. For mean, no need to arrange. Median only you need to arrange. Okay. So let us calculate first mean. What is the formula? Sigma x by n, as you know. So if you make the total 263 divided by 15, first mean answer will be 17.53. So we know very well how to calculate mean. Let us see how to calculate median. For median, we need to arrange. So after arranging, what is the formula? N plus 1 by 2th item. So here you can see 14 has occurred 3 times, right? So median formula, after applying, we get 8th item. 8th item here it is 16. See, if you count exactly and if you locate 16. So median is 16. Let us see how to calculate mode. So mode, highest number of repeated item. So which item is repeated more number of time? Here we need to be very careful. Many numbers are repeating. Okay. First, you see 14 3 times. So number 14 appears 3 times. Next, 16 has appeared 2 times. Okay. Then 22 has appeared 2 times. So which has repeated highest number of time? 14. So 14 is mode. So this is an example for uni or bimodal. Unimodal. Yes. Now, you see, I'm going to test with some multiple choice questions. So let me ask, what is the answer for the first question? What is the most often occurring data called as? Whether it is called mean, median, mode, or variance. Most occurring data. More number of times. Very simple. Can you guess, dear students? Yes, the answer is mode. Very simple. What is the other name for Q1? Fourth quartile, upper quartile, lower quartile, middle quartile. Q1 is said to be, any guess? Yes, it is lower quartile. Now, this is the reference link. We have come to the concluding part of chapter 3. If you have any questions or any doubts, you can contact your concerned course lecturer and get clarified. With this, chapter 3 is over. Thank you very much.